Hello and welcome. Today we look at how to interpret the p-value after you have carried out the chi-squared test of association. A typical application of the chi-squared test in biology is to examine if an association exists between two species, like these two here, labeled A and B. So you carry out the chi-squared test and you get a p-value of 0.57. That's where the confusion begins for some students, because they are uncertain as to how to interpret that, whether or not that means that there is an association or there isn't an association. A nicely organized and systematic way is to focus on your two hypotheses, your null hypothesis and your alternate hypothesis, and to always bear in mind that the investigation should center around or focus on the null hypothesis, which says that there is no association between A and B. That should always be your immediate focus. And then your secondary focus should be on the alternate hypothesis, which says there is an association between A and B. With that focus in mind, then the p-value of 0.57, which is equivalent to 57%, must be applied to the null hypothesis, which simply means that there's a 57% chance that the null hypothesis, which means that there's no association between A and B, there's a 57% chance that that is so. There's also a 43% chance that the alternate hypothesis is correct. So it's quite simple. 57% chance, you accept the null hypothesis. But what if the value here was not 0.57, but something like 0.09? Then what that means is that there is a 9% chance of there being no association between A and B, and a 91% chance of there being an association, or 91% certainty of you wanting to accept this alternate hypothesis. But scientific protocol in biology generally sets a benchmark of 0.05. And only when you get this at 0.05 or 5%, which means only when there is a 5% chance of the null hypothesis being correct, and there's a 95% chance of this alternate hypothesis that you're presenting, there's a 95% chance of that happening, only then could you accept the alternate hypothesis and reject the null. So this is why P of 0.05 is seen as a certain kind of a benchmark, because once you get a p-value of 0.05 or less, it means you accept the alternate hypothesis. And once you have this systematic way of going about your reasoning, even if you get confused, you should always bear in mind that anything less than 0.05, accept the alternate. Anything more than 0.05, accept the null. And of course, the null is always written in a negative kind of language. There's no association. And the alternate always saying that there is an association. And once you have that in mind, then you won't go wrong with interpreting the p-value for the chi-squared test.